we got a customer sent us this image, and basically the task that they were looking at was trying to lay out with tape and a digitizer and all that kind of stuff to reverse engineer this fender. And Sky and I were looking at this yesterday with Matt, and my first reaction to what's going on here is a very common problem that a lot of people get sucked into when they start doing T-Splines, is the fact that there's way too much information here. And the idea behind this is there was an old joke among race car guys about Colin Chapman at Lotus, and the way that they used to design Lotus race cars, as the urban legend went, was that Colin Chapman would build a race car, and then he would start taking pieces out of it until it collapsed under its own weight, and then he would put one piece back in, and that was the design. And true or not, it's the way that you should think about T-Spline stuff when you're doing it. Is you don't want to add. You want to take away until the thing just cannot hold together anymore, and then you want to put the one thing back in. You want to use as little information as you possibly can, as few faces as you possibly can, in order to achieve the result that you're looking for. And in this case, when we look at the layout in here, we've got all sorts of stuff going on in here. The other common scenario with T-Splines is you get a shiny new hammer, which is T-Splines, and everything starts looking like a nail. And you want to use T-Splines for everything. And typically, the way that you want to think about T-Splines, and in this particular case, there may be a reason that that he's trying to model, or whoever this modeler is. I apologize for assuming that it's a guy, but assuming that this person is modeling this this headlight cutout here, typically what you would do is you would overbuild this and then convert to NURBS and trim this, as opposed to trying to model this with T-Splines. And we're going to talk a little bit about that going forward in the reason why you would do that, why you wouldn't do that. And Sky has an extraordinary example of the extreme edges of this that we're going to talk about. And then I've got another model that I'm going to show that talks about how to use T-Splines for what it's good at, how to use Rhino for what it's good at, and how you use the two together to achieve better results than you would get just out of using one or just out of using the other. So the idea here...
Yeah, can I jump in here real quick? No. This is like a really... this is a really...
No, you'll have your time.
Okay, I'm sorry. Whenever you, or at least whenever I do these reverse engineering jobs, you always want to try to back out to, and this kind of touches on what Kyle was saying, is like, what were the giant sort of macro simple shapes that were used initially to make this in this case, the car quarter panel, and then think about all the sort of like secondary down the road operations that were done to that. And so what's interesting with this is it's kind of halfway between being simple and being complicated, right? So it's, in a certain sense, like the flow of the ISO curves that they've sort of mapped out, those are, in general, correct. But like Kyle was saying, like the headlight cutout is never something that you would want to like explicitly model. Like you wouldn't want to like model the boundary of your T-spline along that headlight cutout. You'd rather overbuild that surface and then just trim it back. And then another couple things that we noticed looking at this is there's a couple funky n-gons in here. There's a couple five-sided faces, especially sort of at the rear, going up at like a 45, there's an n-gon in here, yeah, right in there. And so there's a couple different things that you could do. Yeah, so that's going to cause you a bunch of problems. Yes, frowny face indeed. if you want to take the super simple Kyle approach, which is, make it as basic as it can be until it falls down upon itself, you would
or
simply
suspend any and all thought process while you're doing it.
Right, just mash the buttons until it works.
Just mash the buttons with your elbow until something happens.
You could weld together that gap between that sort of rear going panel and the one that goes up at a 45. Exactly. Like, you could just weld those together and you'd have a much, much happier topology, like something that you can go from. Yeah, right. Don't even bridge that. Just weld that and then move that vert, that sort of corner top vert backwards to where it really should be. Yes, exactly. So, Kyle, you want to talk any more about this?
I tell you what, why don't we shoot over to your screen and show, we have a little example about how to lay something like this out, and we'll talk a little bit more about that. We were looking at this yesterday, and we were having a bit of fun with the amount of stuff that was laid out on that screen. There's an extraordinary amount of complication going into that fender, and I want to show you kind of how Sky would handle this. Let's just assume for the purposes of argument that this is a scanned fender, and you are talking about how to RE this thing and reverse engineer it. And so Sky's going to show you how to do this. He does this a lot. He's way better at it than I am. So I'm going to have him demo it, and because he actually has some appreciable talent, whereas I'm good at convincing people that I'm talented when I'm really not. So let's go ahead and let him show this, and then I'll come back and yak at you in a little bit after he's done. Actually, I'll probably stay on and make fun of him along the way.
Well, I'm so talented with this change screen resolution, I can't even click the OK button to get that transparency there. All right, so what we did, well, let me give this one more try. Come on, you. Come on, you. Oh, boy. Enter, add. Oh, boy. Well, we're going to look at this thing then as a mesh. So we're kind of faking some quarter panel data here, like in terms of faking it as laser scan data. We just took a car model and turned this car model into a mesh. So we're pretending that this mesh data here is laser scan data, because typically when you get laser scan data, it's mesh data. And so what you've got for just this quarter panel is it gets really thin up here. You've got this sort of fender arch here. And the rest of it's pretty darn simple and smooth. And then down here, you've got a little bit of a return. And so the way that I would think about doing this, first of all of these quarter panels, they're all going to get made like really the same way in terms of patch layout, which is to say that you're going to have, let me just make a little face here. Okay, so all these quarter panels, they all start in exactly the same fashion. Oh boy, let me turn off my Retopo snap. There we go, thank you. Now let me put this in box mode. So in its simplest form, every single one of these quarter panels is going to end up looking just like this, where you punch a hole in your T-spline, and then you extrude it inwards. And so you really want to try to never make them, like Kyle said, more complicated than they need to be. And so you can see I can grab this here and just kind of bump it out. And we have the very sort of, proto beginnings of what this quarter panel should look like. Now, when you get to something specific like this actual quarter panel instead of like proto quarter panel, let me leave that up for a second. You've got this row of faces running across the top, and then you've got a row of faces that, or sort of this arch here that form this kind of break here, and then you've got these edges here that form the interior. And so when you think about this one in specific, you realize that this row of faces needs to get really, really skinny up in here. And then it can sort of expand out a little bit if you need. But like what I would do with this thing here, let's get rid of our proto panel. And let's get our actual one. And I'm going to turn, in this case, I'm going to turn my retopo snap on. So it's going to just, I'm going to map faces right onto this. And I'm going to use the append face workflow. So I know that I need a strip of faces across the top, and it's got to be really, really skinny, right? It's got to be really thin to sort of make that. And I'm already thinking about how I'm going to extrude in, and I usually want to make those sort of extrusions in. I like to have them sort of come at a 45 here and a 45 here. So if that's what I want, I need to move this sort of here so it can come in at a 45. And then what I'm going to do now is I'm going to just bring a face to like right here. So all I'm doing is alt-clicking here. So I hold the Alt key, and then I just bring it over. And I've got my retopo snap on, so it's retopo snapping as it goes. And I'm going to hit this one here so that it sort of extrudes inwards in this direction. And then I'm going to bring up one more, just like this. So I've got this super skinny T-spline right now. Let me turn this off. Just a little thin strip, and just the beginning of where I want to put this stuff. Then what I would do.
Notice everybody how simple this is. How, you know, he doesn't have a million faces in here. These are all just like, you know, minimal. You always want to start. Just keep saying it over and over and over again. Simple.
Cannot stress that enough. Really cannot. And so, because you can always add verts, you can always add, you know, complexity, geometry, but like Kyle says, the less stuff that you have, the easier it's going to be to edit this thing, and typically the smoother it's going to look. So now, I've got something that I can start to sort of play with, and I'm going to, again, alt-click, and so I'm extruding inwards now. I'm just going to deal with this little strip first. And what I'm going to do is I'm going to take this vert that I created, and I'm going to bring it like into here. And this vert, and I'm going to bring it into here. Okay, so if I try to go smooth on this thing, it just all sort of falls apart because I've got this funky sort of thing going on. But what I can do now is I can extrude this, so I just alt-clicked and I brought a face off here, and then I'm going to select this vert and I'm going to weld it to this vert. And I'm going to do the same thing over here. I'm going to bring this vert kind of over here. And so you can see what I'm doing is I'm trying to line these verts up for now, just kind of along this break between the smooth and this bump out. So now, when I go to smooth it, I've actually got something that, now this is so incredibly loose right now that it's not really going to stick all that well to my actual data. I need more density than this, but it's at least topologically correct. Like this at least gives me a starting point of like where I can build this quarter panel from, and it's at least correct, right? So now that I've got this, I can grab all these, and I can extrude inward here. And so all these points are going to sort of form the basis of the edge here. Okay. So from here, what you can simply start to do is really start to add geometry where you need it in order to achieve the shape that you want. So like places where you would definitely add geometry, let me look at perspective here. In the quote-unquote laser scan data that we have, let me switch back to this. There's definitely a bit of a sharp break right in here. And so you're going to want, in order to model that, extra verts along here. So like this is a great place where you could use TS bevel. That would work very nicely in here. That's a great new command. Let me bring that up here we go. Bevel edges. This is a great way to sort of...
Talk for a second about how that works, about how bevel works.
Okay, so all you're doing is you're adding geometry sort of like along this loop here. And you can do it either as a distance from this loop that I selected, or this series of edges. You can do it as a percentage. So like here it is as a percentage. In this case, because the break is rather uniform, I would use a distance here. And then the segments, in this case, I would use like 2 segments. You can add, you could go crazy and say, like, I want 8 segments in here. And what you'd end up with is this crazy bevel thing. Obviously, we don't want that. We want something like 2 segments in here. These roundness and these ones are a little more subtle in terms of what they're going to do. But I can just come in here and add something like this. Now, why did that go funky? Oh, probably because retopo snap was enabled. Let's turn that off. So let's run that again. And retopo, no. And keep on face, let's say yes. And to positioning distance, great. Okay, now let's do this. Why is that snapping like that?
I wonder if it's because you have distance on. Is there another option like percentage or something? Because I think your struggles there up there on the top.
That's so strange. This is live.
But just one other comment to make, Sky, to clearly kind of state your approach here and how this is different than NURBS. I mean, what you've done is you've really done a very loose approximation of the shape, and now you're firming it up. And in NURBS this would be different. In NURBS you would have almost a crisper or kind of a sharper approach, and then you'd be smoothing that later to get the aesthetics. And so the approach really is almost backwards in that regard, which makes it it's just something to keep in mind. And if you're coming to T-Splines from NURBS. I'm not sure what's going on there, Sky, but if you could also try the TS insert edge command, which could get you...
Yeah, I was just going to say that. So there's more than one way to skin the cat here, and that's to use TS insert edge. In this case, let's do insert edge simple, and let's just put a little more geometry in here. So now what you'll see, and we're going to talk about make uniform a little bit later, but I'll run make uniform on this. So now what you see, the more verts, or the more edges that I add along this sort of break here, the better I'm going to be able to sort of sharply define that kick out. Like the more defined this crease becomes. So let me take it even farther and throw another edge in here. And so this is really how you can really play around with shape and form. So you can see now we're starting to get like super crisp. We've got 3 edges here. And we get this really, really crisp break. So that's sort of how you would control this stuff in T-Splines, which is really, really different from how you do it in a NURBS approach.
So
Any more you guys want to add to this?
yeah, just as far as pacing, I want to move on to the next example, but I wonder, do you have any geometry in the scene that you could match up that edge to? The edge of the wheel.
Not really. Thank you for putting me on the spot.
You could snap a curve to the verts on the top of the fender, and then match
That's
the curve.
true. Right. So yeah, let me unlock this. Let me hide this for a second. Right. So we could draw a curve. Let's just insert a curve through our verts here along this top edge.
This is new for V5, by the way. You couldn't snap to verts in V4.
So if we wanted to, I know where you guys are going with this. We could run TS match, right? So we've got this curve that kind of defines the upper edge here. You can either point edit this thing. Let me turn off my quarter panel. Or you can run TS match and say, I want to match this to this.
Yep. And then there's a whole bunch of options there. But what I just wanted to bring up is that this workflow of starting simple and then getting it tighter matches kind of the final tool that you can use once you've pushed and pulled all the vertices as far as you want to really match to specific detail.
A better matching object. Exactly. So let's just do a couple here. There we go. Okay. So TS match is a wonderful command. Let's take this. Oh, there we go. Take this edge here and match it to this curve. And there we go. So if you can sort of pull out curves that you want to match to, you can do that really easily with T-Splines.
Yep.
And you just, so if you've got targets, if there's something that you really want to maintain accuracy on, that's a super nice way of doing it.
So Sky, just to close this up, if we can skip to, I don't know if you or Kyle has that image that was sent, just to compare this topology approach versus the image that was sent to us. And really the difference as far as the recommended approach here is just to keep the topology really as simple as possible.
Yeah, let's, Kyle, why don't you bring that up? I'm going to make you the organizer, the presenter right now.
And
so yeah, sort of the difference between these two, right?
Yep. Okay. Beautiful. Let's move on because we have a few more questions to talk to. So Kyle, if you can just advance the slide to the next one.